Hi guys, it's Fatih Mehmet. Welcome back to my YouTube channel. And this video is going to be about my EEE-102 Introduction to Digital Circuit Design term project in Bilkent University. So I basically made a Guitar Hero game project. For those of you who don't know, Guitar Hero is a popular game series which was first introduced to the market by Harmonix in 2005. Several different companies have contributed to the development of the game afterwards. The main goal of the game is to hit the sliding notes of a song at the exact time by pressing the appropriate buttons that match the ones with the screen on a guitar-shaped controller. My goals for this video is to inspire future projects for students who will be taking this course in the future, as well as sharing my individual experiences and all the difficulties I've faced designing the project. So let's start off with some background information. I personally love Guitar Hero games, and being able to create one of them was definitely my biggest inspiration behind this entire project. I've programmed the entire game just in VHDL. I did not use any other programming language, and I also used the BASYS3 FPGA board and the TRC11 as external components. So now let's dive deep into those concepts and materials. What exactly is FPGA? An FPGA is an integrated circuit that can be programmed and reconfigured after manufacturing. FPGAs consist of programmable logic blocks and reconfigurable interconnections between them. They are used in a variety of applications ranging from signal and image processing to cryptography and so on. VHDL is the programming language that describes the hardware on the FPGA board, and it stands for Very High Speed Integrated Circuits Hardware Description Language. BASYS3 is the FPGA board chosen for this project. It has USB ports, switches, LEDs, and PMOD ports both for digital and XADC signals, as well as a 12-bit VGA output. TRC11 is the high-frequency radio transceiver, which the word transceiver stands for both transmitter and receiver. TRC11 operates at 27 MHz frequency. It is the radio transceiver which I designed through another course I take this semester in Bilkent, EE-102 Analog Electronics. TRC11 consists of several parts such as different types of amplifiers, voltage regulator, envelope detector, automatic gain control, etc. Well, here you can see the general setup of the game and the cable connections within the devices. Feel free to stop the video or come back if you want to observe the connections further. I will now explain each element individually. Here you can see the main game controller. The design and the manufacturing of this controller is done by me. I did not buy it from anywhere else. There are 8 buttons on the controller that corresponds to 8 different notes in the game. Here is the basis tree, which is the very heart of the project. The PMOD ports on the top left of the basis tree takes the inputs from the guitar controller. And then according to the game logic, it gives the visual and the audio outputs. Here is the TRC11 that is used to give the sound output to the speakers according to the square wave signal it takes from the basis tree. I only used the speaker amplifier part of the TRC11 to turn digital binary signals to sound waves. Here you can see the schematic of the speaker amplifier of the TRC11. Here is a closer look to the speaker amplifier part of the TRC11. The speaker amplifier involves a potentiometer for adjusting the volume level, as well as a sound output. An aux cable is used to connect the TRC11 sound output to the speakers. The design has 3 types of outputs. One of them is the visual output, which is projected onto the monitor via a VGA cable. The other one is the audio output coming from the TRC11. Finally, we also have a score function that is projected onto the 7-segment display of the basis tree. The score function determines how many notes you have hit at the correct time throughout the song.
So we have in the game 2 different songs and 2 different difficulties. You can select them from the BASYS3 switches. So for instance we have Thunderstruck or Smoke on the Water and Easy and Hard as difficulty. So when I turn this switch on, the game starts. Okay, so now let's first try Smoke on the Water from Deep Purple. Okay, so I got 70 out of 80. Yeah, fair enough. Okay, so now let's try Thunderstruck from AC/DC.
Actually, I wanted to add more songs to the game, but the memory of the basis tree did not let that happen. I encountered a warning about the number of LU2 cells required for the design was exceeding the number of LU2 cells present in the basis tree. That was a major drawback since I've always dreamt of a resourceful library of songs in the game. For future Guitar Hero projects, optimizing your design and therefore not approaching the limits of your FPGA board is crucially essential in my opinion. So guys, this was the end of the video. Thank you very much if you watched till the end. And until next time,